Hello everyone and welcome to another video. Today I want to show you a collision detection technique that is often used in games, where you have the situation where you walk into a wall and you sort of slide up against it. I don't know if you've played Counter-Strike, but if you have played Counter-Strike, you know that if you walk up against a wall, you will slide up against it, and this sort of behavior is very common in games. So I'm going to show you how this works. I'm going to show you the formula for it. So let's say we have a wall here. And we want to do collision detection for the bottom part here. And the bottom part has a normal vector that points down like this. And we can describe this vector like this, where the x-axis is 0 and the y-axis is 1. And this is a coordinate system where the negative y goes upwards and the positive y goes downwards. And then we have a character here, and it's moving towards the wall. So it has a vector that points like this. And we can describe this vector like this. We're moving in the x-axis and we're moving upwards in the y-axis. So we have 1, -1 there. And for the normal, we have 0 and 1. Let's call the normal n, and let's call this is our delta position. It's not the position of the character, it's the vector of the movement. So we can call this, let's call it dp for delta position. So now we want to calculate the new delta position when we are colliding against the wall. So to do that, we can say dp is equal to dp minus n times the dot product of dp and n. Okay, so what will this give us? Well, it's going to give us the new vector, and it's going to look like this in our situation here. We're going to keep moving in the x-axis, but our y-axis will be locked. There's not going to be any movement in the y-axis. And this is because we're going to hit the wall, and we're not going to be able to move upwards, but we're going to keep moving to the right. So let's calculate this. Okay, let's start with the dot product here. So what we will do is that we will first multiply the x-axis of our delta position with the x-axis of normal, and then we'll do the same thing with the y-axis. So we have 1 times 0 is equal to 0, and then we have -1 times 1 is equal to -1. And then we'll add these together. So we have 0 plus 1 is equal to, 0 plus -1 is equal to -1. Okay, so that's the result of this dot function here. So this one is done. Then we have the normal times this. So we'll do 0 times -1 is equal to 0. And then we'll have 1 times -1 is equal to -1. Okay, so this is done. And then we're going to remove this from the delta position. So we're going to do 1 minus 0 is equal to 1. Then we'll have -1 minus -1, and this will be 0. And by the way, this equation here returned the vector 0 So my camera stopped recording for some reason. But what I said was that this equation here returned the vector of 0 and -1. And then when we removed that vector from our delta position, we got 1 and 0, which gave us our final result here that we wanted. So that's basically how that works. Just wanted to share that with you. I think this is a really cool way of solving this problem. So yeah, thank you for watching, and I'll see you in the next video.